Welcome back, guys. Today's video is going to be about the concept of absorption and emission. So in order to help us out with this concept, let's take a look at this energy diagram. So this arrow is going to represent energy, and as we move up, we're going to be increasing energy. So it's important to note that electrons can belong to certain energy levels or energy states, right? So these n values that you see, n equals 1, 2, 3, and 4, and so on, actually tell us what energy level an electron belongs to. So if we put an electron in the n equals 1, we are saying that that electron belongs to the n equals 1 energy level. Okay, now you'll often see n equals 1 called the ground state. So if you see ground state, you know that the electron is in the n equals 1 state. Now, when we talk about absorption, right, what we mean is we are going to give this electron energy. In other words, the electron is going to absorb energy. We can draw that with this arrow here. It is going to absorb energy to go to a higher energy level, right? So absorption is giving an electron energy. It can absorb that energy and go to a higher energy level. Now, let's imagine that we have this electron. And instead of absorbing energy, let's say we put it in the n equals 3. And we want to actually put this electron to the n equals 2, right? So if we want to go from a higher energy level to a lower energy level, what we're going to have to do is actually emit energy. So that's the difference between absorption and emission. Absorption is giving an electron energy so it can reach a higher energy level. Emission is taking an electron at a higher energy level and bringing it to a lower energy level. Now, in order for this to happen, we're actually going to have to emit some energy, right? Now, once this electron can emit this energy successfully, we can then bring it to the n equals 2. Now, I want to take a second to talk about what we are actually doing when we transfer these electrons from one state to the next. So let's go back to our original example. So let's say we have an electron in the n equals 1. And we want to bring it, let's say, to the n equals 4. We know we are going to have to do absorption here, right? If we want to go from a lower state to a higher state, we want to go with absorption. Now, what is this electron absorbing? Now, this electron is absorbing energy in the form of a light wave. Okay? And if you look at another video on my channel, I talk about how to calculate the energy associated with a light wave. Now, in this video, I want to talk about what the energy of a light wave is called. The energy of a light wave is actually called, it has a special name, it's called, if I can open this marker here, it's called a photon. Okay, so photon describes the amount of energy that a light wave carries. Okay, just to reiterate that. A photon describes the amount of energy that a light wave carries. So if you were to say that this electron absorbs energy, what you're really saying is this electron absorbs a photon, an amount of energy, to absorb that energy and reach the n equals 4 or whatever energy level you are trying to get that electron to. Now, let's say we're back to our second example where we had an electron in the n equals 3. And we were trying to get it to the n equals 2. We know we are doing emission here. We're going from a higher energy level to a lower energy level. Now, whether you're doing absorption or emission doesn't matter. What you're still doing is working with photons. The only difference is when you're absorbing, you're hitting that electron with the photon so it can absorb it to go to a higher state. Here, we're still working with photons. However, we are emitting a photon, right? This is still a light wave that carries that amount of energy, that photon, right? And we are going to get rid of that energy so it can reach a lower energy state. Now, the reason I bring that up is a really important concept. The energy of a photon is always positive. Now, how is that the case? So, you might think, well, okay, that makes sense if we're going from n equals 1 to n equals 4, right? We're going from a lower state to a higher state. You're going to give it the energy. That energy is called a photon. We're going to absorb that, right? The energy is positive, right? Now, even if we're going from a higher state to a lower state, let's say the n equals 3 to the n equals 2, we are emitting a photon, right? So I agree with you that the electron itself will lose energy, right? It will actually have a negative energy change associated with it, going from a higher state to a lower state. But if you are calculating the energy of a photon specifically, that energy is positive, right? The amount of energy that you're emitting is still a positive value. This electron is losing that positive amount of energy so that it can reach a lower energy state, right? So whether you're absorbing or emitting doesn't matter. You're still working with a positive photon. It just matters whether you're absorbing that positive energy and going up or releasing that positive energy and that electron's going down. So how do you calculate the energy of a photon, right? So if we want to calculate this energy change, right, how much do we have to give it to go from a certain state to another state? We're going to use this formula. The energy of this photon here, right, that's always positive no matter what, is negative 2.18 times 10 to the negative 18 joules divided by the n final squared. So the n value that you want to reach at the end minus, so keep track of the signs here, minus 2.18 over n final squared in parentheses, minus, in another set of parentheses, negative 2.18 times 10 to the negative 18 joules over n initial squared. Okay, so just as a review, absorption and emission, going from lower to higher for absorption, higher to lower for emission. That energy that you are either absorbing or emitting is always positive, right? We just know that in absorption, we're absorbing a positive amount of energy or a photon. In emission, we are releasing a positive amount of energy or that photon, right? So let's try out a practice problem. It says calculate the energy of a photon for an electron going from the n equals 4 to the n equals 2. So let's do it, right? So we have an electron and the n equals 4, right? And we're trying to go to the n equals 2, right? So what we're going to have to do is we're going to have to emit a photon, right? So we can actually look ahead to part B. Is this absorption or emission? This is emission, right? We're going from a higher state and we're trying to get to this lower state. So using this formula, we can calculate the energy associated with this process, right? E equals, so we're going to find E equals, right, negative 2.18. Here, I got myself some room here. This E equals negative 2.18 times 10 to the negative 18 joules over our n final squared. So our final destination is n equals 2. So I'm going to say that's 2 squared, right, minus our negative 2.18 times 10 to the negative 18 joules over, what is my initial n value? My initial value is 4. So I'm going to do 4 squared. So make sure you get this value, and then subtract them. The energy associated with that process, right? Let's think about it. Now the electron, I should say, is losing energy. I agree that it's going from the n equals 4 to the n equals 2. So on this energy diagram, it's going down. However, if we're calculating the energy of the photon, right, that is going to be a positive value that we are leaving or getting rid of that, or what I should say, that photon is leaving that electron with a positive value, right? That is going to be a positive value for that photon, and that electron is successfully going to reach the n equals 2 state. So this is how you work through an absorption and emission problem. Thanks for watching.